All right, hello girls. This is Hallie. This is for Hallie Minnick and for Avalee, and we are starting chapter 3. This is measures of center, so like mean, median, mode, range. There's also a couple other ones sprinkled in there, like the interquartile range. There's also the mid range, which we haven't ever talked about before, so we'll have to hit those pretty hard. But for the most part, this is going to be not so bad. But here's things to remember. So when you are doing the mean is the what? Average. The mean is the average. So what you're doing, and here's the symbols, because in statistics they use symbols a lot of times. So this means the sum. This little e means the sum. Put that down. The sum of all the x's. So the sum of all your data values. Each x is a different data value. So it's saying take the sum of all the data values and divide by n. And n is the number of data values. Okay, so you take the sum of all your values, you add all those values together, and then you divide by the number of numbers that you have, right? That is what the mean is in symbolic form. Sum of x divided by n. That is that. Got it? That is the mean. Okay, now, here's the things that I want you to remember. We know how to find the mean. We know how to find the average, but here's the important parts of it, okay? So, things that we need to pay attention to, okay? As far as, like, where is the center of the data, and like what do outliers do to the mean? It's something called resistance, okay? So sample means draw from the sample population tend to vary less than other measures of center. Okay, whatever, we'll skip over that one. The mean of a data set uses every data value. Uses every data value, okay? If I am finding the range, right? Do you know what the range is? We'll get to the range. The range is the biggest number, you don't have to write that down, but the biggest number minus the smallest number, right? Does that use every data value to calculate the range?
Not really.
No, just the big one and the small one. I have no idea what the other numbers are in between when I'm finding range. But the mean takes every data value into consideration. So if I'm doing like a class average, right? And I'm going to say everybody, like you guys are all going to take a test, and then I'm going to average your scores, and that grade is going in your grade book. You're going to probably be getting on some people in here being like, get your butt in gear so that you're not bringing the class average down, right? You know what I'm saying? Because every value is taken into consideration, right? Okay? Every data value. All right, the disadvantage to the mean is that just one extreme value, like one outlier, can change the mean substantially. If you have all the grades in a grade book and all of a sudden you were gone and I drop a 0 in there, it tanks it pretty fast, right? One outlier makes a substantial difference, okay? Using the following definition, we say that the mean is not resistant, okay? If you hear the word resistant means it resists, okay? If somebody resists something, that means like they stand their ground, right? So if you have a mean and you throw an outlier in there, does it stay in the same spot? I'll say that again. If you have a mean, if you have your average, and you throw a 0 in there, does it stay the same? No, it does not resist that 0. It absorbs that 0 and it pulls it way down, right? So it is not a resistant value, right? Mean is very much affected by outliers, right? Maybe you're used to getting like 20% and then all of a sudden you get 100%. That's going to pull your grade way up, right? Okay, so the other end works as well. High outliers, low outliers end up really causing some change to the mean, right?
But it doesn't affect it if you have like 120s.
Say that again.
Like if you have a bunch of small numbers and you get a 1 it doesn't affect it as much as if you have like 3 small numbers.
But like if your grade's like a 98 and you
Depends on
fail
how many
one
grades there
assignment,
is,
then it
too.
takes it to like a
Yeah,
70
exactly.
and
Correct.
it's so dumb.
Correct.
But
Correct.
if you have 98 from like
Now, it also, another variable to take into consideration is the weight of your scores. So like homework in this class is weighted smaller than what tests are weighted, right? So if you tank a homework assignment, it's not going to pull your grade down as much as if you tank a test. Does that make sense? Okay. So that's another variable to take into consideration that they don't usually do for mean. We will in this section talk about weighted averages. But that's another thing that plays into that. Yeah. Okay. Yeah. All right. So resistant. Something is resistant if it doesn't change very much. Okay. So for example, like let's say I have the number. Let's just talk mean, median, mode. Mean, median, median, mode, and range. Okay? All right, we're going to talk about those, and here's my data set. So let's say I have a, let's just talk scores, right? Let's talk some grades. Let's say I have an 88, a 90, a 91, a 92, a 92, a 97, and a 100. I have 2, 4, 6, 7 scores, okay? All right, let's find the mean. Let's find the mean of those scores. Somebody want to add, yeah. Do that. Find the average of those scores. 92.86, so 92.9. All right, now I'm going to do one thing. Rem, take that number, put a 0 in. With the 0, let's look at what happens. Woo! That's a big drop. That's
Like
over
11
10 points. That's 11 points just with 1 0 in there. Okay, the median, the middle number, right? So if I'm looking at this range right here, my middle number, right? There are 7 values, 1, 2, 3, 4, 5, 6, 7, right? The middle value will be a 92, right? The median is a 92, okay? Now, if I put that 0 in there, now what becomes my median? Now I have 8 numbers. How do I find a median with 8 numbers? I have 2 middle numbers, right? So I average them. So my median goes from a 92 to a 91.5. Lots of change? Not lots of change. Okay? All right, the mode. Without 0 is a 92. With 0 is a 92.
Well, where are we getting? Oh,
Mode is the one that occurs the most. Sorry, yes. Mode is the one that occurs the most. So we have a 92 that appears twice. That's my mode, right? So if I put the 0 in there, still 92 appears twice, right? And then the range from 100 to 88 is 12.
And then this one will be 100.
Whoo! Man, if I throw that 0 in there, now my range is 100, okay? So let's talk about which ones resist change. Which ones resist change?
Median. No mode.
The mode is the most resistant, right? Most resistant. Now again, resistance means it doesn't change, right? Resistant means it resists change, right? So it is the most resistant. It didn't change at all when I plugged that 0 in there, right? Which one is the next least resistant? Median. That's pretty resistant too.
But
Okay, it did change slightly, but it's going to be one of the lesser resistant ones because it's only going to shift like just a little bit. When you throw one outlier in there, it's going to go from this number to like a half a step down, right?
Stupid. Where did you get
12 for 12 for range. 100 to 88.
Oh,
Those are mine.
okay.
Yep. Okay. All right. Median and range. Those two are going to be not resistant at all. Not resistant. Not resistant. They are going to be very much affected by an outlier. Does that make sense? Okay. Do you see that? Range is very, very resistant. Very not resistant to an outlier. He's going to change a lot. A lot. Now, does it usually go in that order? Range is the least resistant. It's going to change the most. The median changes the second most. The median changes just slightly, and then the mode shouldn't change at all. Is that always how it works?
Not always. I don't know. Maybe
Most of
you should ask
probably
that
not
question
always.
again.
Ask that question again. Okay. So let's just talk mode and range. Is it always true that the mode is the most resistant? He won't change at all if I throw an outlier in there.
unless the outlier is.
Unless the outlier is repeated,
But then it wouldn't be an outlier, right?
So, yeah.
So yes.
So the mode shouldn't change, right? Your mode shouldn't change. So he should always be the most resistant. All right, will the range change the most out of all of them? Yes, with an outlier. Yes. And then the median and the mean. Is it always true that the mean changes more than the median?
I don't know.
Usually. Yeah. So usually it will follow this trend. Not 100% of the time, but like
Median can change a lot.
most of the time.
The median changes a lot. The mean won't.
The only time the median's going to change a lot, maybe more than the mean does.
The middle jumps from like 30. to 50,
Let's say I've got, oh gosh, let's say, let me come up with I'm going to make a small data set, but I'm going to make it huge. Ready? Let's say I have like a 50, a 52, a 90, a 95, and a 100. I don't know. What's my middle number now? 90, right? Okay, so let's do this. I'm just going to deal with these numbers, okay? So my median right now is 90, right? Okay? If I toss a 0 in there, my median goes from that to being the average of 52 and 90, which is 142, which is 71. So now my median goes from 90 to 71, right? My average, or my mean, without the 0, and that's through the average with the 0. I'm trying to do like a big jump between my middle numbers so that median goes way down.
So how many numbers is that? 6?
5 numbers without 0.
Okay. With the 0, it's 64.5. Without, it's 12 point. Wait, that's
Other way
I
around.
accidentally took the. That's 5 numbers without the 0.
Yes.
77.4.
77.4. So, and that is the only case where the median will jump more than the mean.
Yeah.
Yeah. Yeah. Is where you have like some middle numbers where the mean, like the median jumps right over top of a huge gap. Okay. That's the only time that will happen. Otherwise, every single other time, this is what will happen. Range changes most, mode changes least, right? That's how it works, okay? So we talk about resistant versus not resistant. Good, good? All right, let's talk mean. Here we go. We have some values. We have 38.5, 55.6, 22.4, 14.1, and 23.1. Find the mean of the first 5 data pieces. Add them up. I'm going to do the sum, and I'm going to divide by 5. Sum of all the x's divided by 5. Somebody want to take a stab? I'm going to say 26.
26 point.
No way.
What?
Look at that.
Where are we getting? Hold on.
Did I type in not the right things?
I got 30.7.
Okay.
Hold on.
I want it to be Megan because, like,
23, 14, 22.
I think I might have forgot the 22.
Yeah, you definitely did.
okay. Okay. Ah, dang it.
It's 30.
30.74. That's my average. Megabits per second. That's the average.
You trust me.
It's like, I always
Okay.
like hate when you run.
And these are airport data speeds. Okay. Then they're going to start throwing some numbers at us. All right. So that was average. We know how to find the average, right? The median is the middle. Okay. So here we go. We're going to find the middle of an odd number of data, and we're going to find the middle of an even number of data. All right. So here we have like 5 numbers. 1, 2, 3, 4, 5. When you're finding the median, you have to put them in order. 14.1, comma, 22.4, comma, 23.1, comma, 38.5, comma, 55.6, comma. All right, here's the deal. Long gone are the elementary days where you cross, right? Okay? We're not doing that anymore. If you have 5 numbers in your data set, okay? 5 numbers in your data set, and you split them in half, are you going to have a middle number? Yes. Okay? You will have 2 numbers over here. You will have 2 numbers over here, and you will have 1 number in the middle, which will be the third number. True? Okay, so let's chat. Let's say I have 97 numbers. I am not going to sit and cross, because I'm going to lose track, right? So, will you have a middle number if you have 97 numbers? Yes, okay? So if I take 96 and I divide that by 2, that is 48. So I will have 48 numbers over here. I will have 48 numbers over here and 1 number in the middle, which will be the 49th number from either end. Does that make sense? Way faster to do it that way than to cross. Got it? Okay? All right, I know that's what we used to do in elementary school, but don't do that, right? Like, it's not that big of a deal when you have 5 numbers. Like, you could sit and cross, like, whatever, right?
That many pieces of data, are we?
You might have, like, 20-some. Right, so even if I have, like, 23, will you have a middle number?
Yeah.
Yes. 22 would be 11, and 11 here. So my 12th number. That's way faster than cross, right? Okay? So find that middle number. It will be the 12th number from either side, right? Okay? Way faster to figure it out that way. All right, so my middle number here is 23.1. That is my median. The median. Yeah, yeah? Okay, now they're going to add a number to us, right? And I'm going to go up since these are all in order. Which number did they add? They added the 24. All right, whatever. I'll write them out again. 14.1, 22.4, 23.1, 24.5 is added in there. Then I've got the 38.5, and I've got 55.6. And I have 6 numbers. Will you have an exact middle number? No, you have 2 middle numbers, and they are these 2. And now what do I do?
Average.
The average. You add 23.1 plus 24.5, and you divide them by 2, and that gives you a median of what? I don't know. 23.8?
23.8. I think so.
I don't think that's right.
23.8.
7. Yeah, you're right. 23.8. I lied. Yep, 23.8. Good. Okay, happy with that? Even number, you have to take the average. Odd number, you have an exact middle number. Good? Okay. Yeah. Important properties of the median, if we go right above that. It is a resistant measure. It does not change very much, typically. The median does not directly use every data value. Does not use every data value when you're finding the median, when you're finding the middle number. Okay? Does not use every data value. Okay. All right. Important properties of the mode. The mode can be found with qualitative data. What does that mean?
Like categories.
Categories, right? Like the mode in here would be, for like eye color would be, I don't know, is it blue? Is blue the most prevalent eye color in here? So we have a mode that is blue for eye, right? Okay, because that is the most prevalent eye color. Yeah? So mode can be found with categorical data, right? Okay, a data set can have no mode, one mode, or multiple modes. Now, it is important to know that if it has no mode, don't put 0 for the mode. Why don't you put 0 for the mode if it has no mode?
Because 0 can be a
0 could have been a number in your data set, right? Okay, don't just put 0, put no mode. Got it? When you're finding the mode, you can have I love this. Are you ready? Watch this. You can have something be bimodal, which means it has 2 modes. So if it has 2 numbers that repeat 3 times, then it's bimodal. Okay, what happens if one number repeats 3 times and one number repeats 2 times? Are they both modes? No, it's just the one that repeats 3 times, the one that occurs the most, okay? You can have something that is multimodal, so you can have like 7 modes if they all appear 3 times, right? Okay? When a known data value is repeated, we say that there is no mode. When you have ice cream with your pie, it is called a la mode.
Is that something?
Ha.
That's a turd.
Okay, all right, whatever. Anyway.
I agree.
No mode, multimodal, bimodal. There you go. Find the mode. Which one is it?
0.3.
0.3 is the mode. 0.3. Okay, 0.6 appears twice, but 0.3 appears more, so that is the mode. Got it? Good? Okay. All right. Let's do mid-range and then we'll stop. Okay? Are we ready for that today? Yeah. And then I'll give you some homework. Okay? Now, this is the one that we don't know yet. All right? So lock in. Give me like 15 seconds to explain what mid-range is, and then you'll be good to go. Okay? The mid-range is what the median should be. The mid-range is what the median should be. Okay? What the median should be. So let's say I have a number that is 0. And let's say I have a 90 and a 95 and a 99 and a 100. Okay? The median of this data set, the regular old median is what? 95. Okay? If I'm looking at the high and the low number, what should the middle be? What is the mid-range? Like the middle of the range, right? The median should be 50 because my low is 0 and my high is 100. Does that make sense? So in other words, the mid-range is taking the range and dividing by 2. Okay? It is the high number, low number added together divided by 2. Got it? Actually, that's not whatever. It's not the range. It's not the range. It's the max plus the min divided by 2. It's finding the average. I'm going to say the average of the high and low. It's the average of the high and low is what the mid-range is. You average those two together to figure out what the middle number should be, right? What the middle number should be. That's what the mid-range is. The middle of the range, right? Okay? Important numbers about the mid-range. Because the mid-range uses only the maximum and minimum data values, it is very sensitive and it is not resistant. So if I throw an outlier in there, look at how my median and my mid-range differ. Not resistant, right? The mid-range is going to change a whole lot if I throw an outlier in there. All right. The mid-range is very easy to compute. The mid-range helps reinforce the very important point that there are several different ways to define the center of the data, okay? Now, here's another point. The median and the mid-range. If those two numbers are the same number, your data is likely to be a normal distribution. Okay, let's chat about that. Normal distribution does this, right? So if I'm talking my low number and my high number, and if I divide them in half, that's going to be like right here in the middle, right? And my median should be that same number, okay? But also, that number should also be the average, the mean, and it should be the mode because it occurs the most, right? So the closer your mode is equal to your median, is equal to your mid-range, is equal to your mean, the closer those are, the more normal your distribution is. Does that make sense? The more symmetric it is. Got it? That makes sense? Yeah. Those numbers will be almost the same number if you have a normal distribution. Okay, let's do this one and then we'll be done. Find the mid-range. I got to put these in order again. 14.1 and 22.4 and 23.1 and 38.5 and 55.6. Okay, we said the median, the middle number was 23.1, but what should the middle number be?
34.
If I add 14.1 plus 55.6 and I divide by 2, what should that middle number be where?
34.85.
34.85. That is the mid-range. Got it? 34.85 is what the middle number should be. So my middle numbers are actually lower than what they should be, right? Because I'm kind of skewed to the bottom end, which means I'm right skewed, right? Okay, whatever. Anywho. Good? All right, rounding, by the way, also go one more decimal place than the original data value gives you. So like here, we had 1 decimal place. So when you calculated the mid-range, you gave me 2 decimal places. That's exactly what I'm going to do, right? You give 1 more decimal place. Then I know we're supposed to do sig figs and all the things, and you guys know what that is right now. But they say their rule is if you're doing a calculation, you do 1 more decimal place. So you round to the nearest 2 decimal places if there's 1, right? Good? Okay? All right, there you go. Homework. You can do the, I don't know.
I'm confused on number 2,
I was
Number
gonna say
2?
I am too.
which is the first one.
Oh, USA Today poll published a list consisting of state tax on each gallon of gas. If we add the 50 states' tax amounts and then divide by 50, we get this many cents. Is that value the mean amount of state sales tax paid by all U.S. drivers?
Well, not everybody gets the same amount.
It's the average,
Same
you know?
amount.
No.
So they average, like in Nebraska, our average is $3.85, whatever it is. In California, it's $4, whatever. If they average all those numbers together, is that the average amount that all U.S. drivers do?
No, because different states tax different.
But it doesn't matter. That doesn't more so matter.
No, what if you drive in an electric car?
Maybe. And there's more of those in
California.
California. There are way more drivers in California than there are in Nebraska. So they should be weighted proportionately, right? If we're talking about the average for all U.S. drivers, we need to weight Nebraska less than we weight California. True?
So no, because it's weighted.
No, because they should not be weighted equally. And they are in this scenario, right? That is not going to represent the average of all U.S. drivers. It is representing all the states equally, and they should not be. Got it? Okay. You can do number 4. You can do 5 and 6.
And 22.
And you can do 22.
And you
So
can
from-
And then let's do,
Let's not.
and you can do 23, I guess, if you want to. So you can do the front page and then you can do 23 on the back. And you've got like 15 minutes. So you got lots of time. Okay, good? All right. Yes.